So here we have opened the pattern window, and today we are going to look at how to solve the problem of a plate with a hole. So let me create a new database file. Let me name it as plate with a hole. Here it asks for model preferences. Just click OK. This is fine. And now for the first thing what we have to do is create a geometry for the plate with the hole. So let's create 4 points for the hole. Let's make this plate as 100 by 100. So the first point will come at 100, 0, 0. And to visualize the point that we have created, click on this, and you can see the point has been generated here. And the next point will be at 0, 100, 0. And the next point will be at 100, 100, 0. So here you have we have to create one more point that is at the origin. So here we have the point at the origin. So we have 4 points that forms the corner of our geometry. Now let's create curve. So if you have checked this auto execute, then it will automatically create the curves. Now let's connect these diagonals as well. Okay, now since this is a plate with a hole, we have to create the circle. So for that you go to create curve, and instead of this point you choose 2D circle here. And now you can have two options, input radius, calculate radius. So we'll be inputting radius. This is a plate of 100 by 100, and we can have a hole of 5 mm radius. And here it auto execute is on, and it asks for center point list. We want the circle to be here. So if you look at this particular this side of this geometry, this side of this square is 100. So we want the circle to be at the center, which is 50, 50. So x is equal to 50, y is equal to 50. So here we will have this, we will have the hole created. Since this circle is too small, I will click undo once, and then I will click 10. So now here we have a hole of 10 mm. So here we have a hole of 10 mm radius. Now what we do is now click on create. Now click on create and choose edit, and here come to this edit curve. Click on create point, and here choose the option intersect. So create point intersect. So what this does is that when two curves are intersect at that particular point, it will create a point. So here I will click this curve and this curve. So you can see that the point has been created here, where this diagonal and this circle means their points has been created. Similarly, I will click here this curve, and the point has been created. Now I will go to edit curve break. So what it's going to do is it's going to break the curve at that particular point. Remember here auto execute is on and delete original curves is on. So here first you have to choose the curve list and the breakpoint list. You click here, and it will ask, do you wish to delete these original curves? Yes, we are deleting this original curve. That means the original diagonal that was there, it is deleted, and we have here curve 1 and we have another curve 2. Similarly, do click on this curve and click on this point again. So now what we have is we have 3 curves here, 1, 2, 3. Similarly, repeat this process for this other diagonal as well. Yeah, now here we have 3 curves. Now what we can do is we can delete curve, and we can select all this. So these 2 curves, curve 11 and 14 has been selected. Now click on apply. So now these curves has been deleted. That's why you will see a black color. That's why you will see the shading has changed. And to visualize this, you can just click on refresh graphics, and yes, here you see. And now what you need to do is essentially what I want to do is make 4 quarters and mesh it separately. And that is why I'm doing all these things. Now what we can do is again go back to edit, curve, break, and here choose this curve and click on this point. So it will again ask, do you wish to delete original curves? Yes. So now we can see this. Now again I want to click on this curve and this point. Yes, now we can see this segment is there. And now again here I will click on this curve and this point. Yes. So now you see now I have 1 quarter here. This quarter has one curve, 1, 2, 3, 4. So we have 4 curves in this quarter, and similarly here also we have 1, 2, 3, 4. So what we have to do now, first we will give it some properties, isotropic. So I will give this as aluminum, and in the input properties I will give it as 70,000 and Poisson's ratio of 0.3. okay. Now click on apply, and you can see that this material aluminum has been created. And now I have to create property for this property. What we'll be doing is a 2-dimensional mesh, so we have to give a 2D property. So 2D shell property, so you can see this option over here. So let's give it a property name, plate property, default options. You can keep the default options. Go to input property, and here you can see material name. So here there is an option to select material. You click here and then choose the material here. So we have defined this material previously, that's why it is showing over here. So once you have chosen this, you need to enter thickness. Let us consider the thickness of this plate is 1 mm. So let's enter that and let's click OK. Now we will click apply, and you will see that the plate property that we just now entered has been created. Okay, now what we need to do is, now we'll go to the meshing tab and we have to mesh this. So before meshing we have to do something that is called mesh seed. So basically mesh seed we do to tell this to tell Patran how many meshes it need to create. So basically meshing is discretizing the geometry into finite elements. So but the question is, how many elements do you want, in how many equal parts, in how many parts do you want to mesh it, and what is the way in which you want to mesh it, what is the way you want to structure that mesh. So for that you have create mesh seed. So you have to create mesh seed. Basically it will allow you to divide these curves into parts that you want. Suppose I can divide this curve into 10 parts, then I will use this option, a number of elements, I will use 10, and then here I will click on here. So now I will have, if I zoom in here, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 divisions. 10 divisions have been created. So similarly I can choose here and I can create 10 divisions, and here also 10 divisions, and again here 10 divisions, and here 10 divisions. Now what I'm going to do is that, okay, here also 10 divisions, here also 10 divisions. Okay, now we have divided these curves into equal parts. Now you see why did I use a mesh seed of 10 here and 10 here, because this way we can have a uniform mesh, as you will see in the next step. So now click on create mesh, and here you have to choose the option of 2 curves. So we are meshing by the option of 2 curves. That means it's going to mesh between 2 curves. Okay, now element shape is quad. We can give tria and quad as well, but here we are going to choose quad. Okay, now it will ask for curve 1 and 2. If this auto execute is look that this auto execute is checked on. Now click on this curve and click on this curve, and now you see that a mesh has been created, and you see how it is well structured. Similarly click on this curve. Now what you do is, now go to sweep, go to transform, element, mirror. Okay, now what you do is keep these default options on. Now there is an option to select element. So here you just drag and select all these elements. So basically what we are trying to do is we are trying to mirror these elements to this side, okay, and we want to select the normal to the mirror, and we want to select the plane that is normal. So we have a mirror here, and the normal to the mirror is this in y-axis. So 0.1 refers to x-axis, 0.2 refers to y-axis, and 0.3 refers to the z-axis. So I'll click apply. So now you see that this is mirrored, but it is mirrored somewhere else, and the reason it is because we have to give an offset parameter over here. So I will undo here and then go to offset and give it a value of 50. Now press okay, now you can see that that elements have been mirrored perfectly. The 50 is the half width of this square. Similarly, now go to create mesh 2 curves. I'm just repeating the step as before. So click on the first curve, click on the second curve, and you can see the mesh has been created. And now what I have to do is, now I will go to transform, element, mirror, and now I have to choose the elements. Basically these elements I have to choose. So now you see that if I'm trying to select, it's very difficult to select, and other elements, so the other elements will come in between. So what I'm going to do is delete this, and then here we have an option called polygon peak. So it will help us to select the elements better. So as you can see in this step, so I'll click here and then just move my mouse till here and then give it another click. Basically you can create any kind of shape of a polygon you want, and you place your elements within the polygon. So now you can see all these elements have been selected, and I will zoom in and you can see that yes, all these elements have been selected. So now you see you have to choose the mirror, that is you have to choose the plane normal to the mirror plane. So here we have mirror here and its normal is x. So you choose 0.1 and here you have it. So we have a plate with a whole mesh is ready. But now there is a problem with this mesh, that since we have created this mesh separately, this mesh is not connected. In order to visualize if this mesh is connected properly, we have an option called equivalence. So here you can see in this option equivalence, you click, and then here there are two options. One is the display type, free edges, and preview nodes. So if you click on the display type, free edges, it will show what are the free edges of this mesh. Now I will click on verify and you can observe what is going to happen, and you can see that these are all the free edges, but there is some problem. Now you see that the free edges of a plate with a hole, what do you think the free edges of a plate with a hole looks like? This will be one free edge, this will be 2, this will be 3 and 4. We need to have 4 edges of a square are the free edges, and since we have a hole, this is also one edge, but right now it shows even this as a free edge, this and this and this. This is a typical problem in meshing, that these kind of free edges will be generated. So this we have to this should not happen, and we have to rectify this problem, and then, but we have a conveniently good or easy way to rectify this problem. For now I will reset it back to the original mesh, and here we have another option called preview nodes. So essentially we have nodes at each of these points, and in order to visualize these nodes, you can go back to home tab, and in this MISC you have node size. So once you click this, you can see the nodes. So now you can see that there are nodes. I will zoom in and you can see each of these are nodes. So basically in finite element analysis, we have an element, and each element has a couple of nodes. So these nodes of one element is connected to the node of another element. So that's the way it is. So this element is sharing its node with this element, this element, this element. So this node is being shared by 4 elements. But now when I will turn this node size back to, so what happens is that it will increase the node size, or it makes it visible and invisible. Okay, now when I click on preview nodes, you can see some of these nodes. So what it shows is it will show these duplicate nodes. So what we have here is that we have multiple nodes here, and that is why it is showing. So basically there are 2 nodes over here, and that shouldn't happen, because this node, there should be only 1 node and it should be shared with 4 elements. But now that is not the case. What is happened is that there is 1 node that is shared between these 2 elements, and we have another node that is shared between these 2 elements. But that's not what we want. The same issue is what you can see by clicking on the display type. Okay, now the easiest solution is go to equivalence and click on apply. So now you can see that geometric equivalence completed, 44 nodes deleted. So now I will refresh this. Okay, and now when I reset and click on the free edges, now you can see that the free edges are these 4 sides and this hole. So so now we have a good mesh to do our finite element analysis. Now let me reset this. Now what is missing is that we have created geometry, we have created our material, we have created the property, and okay, now in this property we have to assign this property to these elements. So these elements do not have a property now. So click on your property and select this application region, and here entities, you can, if you look at these options, we have surface, we have tri element, quad element, shell element. So here we have quad element, so we can click on this quad element and we can drag and select all these elements, and you can see that 1 to 400 elements have been selected. And click on OK, click on apply. Okay, if it asks you to overwrite, you just overwrite that. For now, this properties has been created, and now so now we have created everything except the loads and boundary conditions. Loads and boundary conditions is also a very important part in finite element analysis. So click on this loading tab and click on create displacement nodal. Let us give it as a name fix. Let's give it as name of fix, and the input data, what I'm going to do is enter 0, 0, 0. I'm going to fix the left end and I'm going to apply the load at the right end. So click on application region and click on select nodes and select these nodes at this end and add, click OK, click apply. So now you can see that this end has been fixed by 1, 2 and 3. And now I have to apply a load over here, and here you can see I have to apply some kind of distributed load over here. So here we have CID distributed load. So create CID distributed load UDL, and here the target element should be 2D and not 3D. Okay, and in the input data I have already entered here 100, 0, 0 in the edge distributed force. So I'm going to apply the force at these edges, and that too at the free edges. Okay, and not at these faces. So you enter 100, 0, 0, click OK. Click on the select application region. We have to select these free edges. So here we have 3 options called tri or quad element, edge of element, and free edge of element. So we have to select free edge of element and make a and drag and select these free edges, and once these edges have been selected, click on OK, and then apply, and then you can see that the CID distributed load has been applied. And if you look at this value, since this is a distributed load, it will be in Newton per mm or Newton per meter or whatever the units that you have assumed. And now we have applied the loads and boundary conditions. So now let's now we'll come to analysis tab and click on entire model. So we have analyze entire model full run. So we have job. So you can enter any name you like. job name plate with the whole plate with the whole 1 2 3, and then what is important is to choose the solution type to be linear static and click on OK, and then I will click on apply. So either you run it in the Nastran, in the pattern itself, or you run separately by exporting the BTF and then run it using Nastran. So I'm running using Nastran. This is a job file that I have created, pattern with whole 1. So click on open, run. So it will take a couple of seconds to run. So once the analysis is completed, click on HDF5 option here. So we have access results, attach HDF, result entities, and now go to results file and then choose plate with the whole 1.h file. Now click OK and click apply. So it shows some error. You just click on apply again. Okay, I think the problem is because we have not fixed the degree of freedoms because this is a two-dimensional problem. We have to fix the degree of freedom of in the z direction. Okay, so in addition to this this boundary condition, we have to create one more boundary condition, that is fix 3, or the fixing the z degree of freedom 3 for all these nodes, so that since this is a two-dimensional geometry, we should not allow this geometry to to move in the z direction. We should move only in the x and y. So we'll go to first input data, and then keep it as only empty and 0. Click on OK. Select application region. Application region will be all these nodes. Click on add, click on OK, click on apply, and you can see that all these nodes have been constrained in the z direction. Now you can go to analysis tab and click on entire model. So you can see analyze entire model full run. So give some job name plate with the whole anything. The most important point is that you have to go to solution type and see that this is linear static option is selected here, and click on OK. Now you can click on apply, and analysis will run. So either the analysis will run, you can run it through pattern itself, or what you can do is you can import. So what I'm doing here is that I'm using Nastran to run this analysis. Either you can run it in pattern itself directly, or you can use Nastran to run it. It will take a few seconds for this size. It will take a few seconds to complete. Now click on HDF here, access results here, HDF5. So here access results, attach HDF5 result entities. Now select the result file. So you have to choose the result file that has been run successfully. Now click on OK, click on apply. And now you can see that here it shows processing results and end attach result file. This means that analysis has been completed successfully. So now you can go and see the results. So I'll click on the results tab, and here I have create, quick plot, and fringe results, stress tensor, and here quantity will be one misses, and click on apply. And now you can see, I'll just click on this thing again, and yeah, now you can see where the stresses, one misses stress. So here we have a scale which shows the maximum stresses. So the maximum stress is 293 point something. So you can zoom in and you can see that this is the point. So in a plate with a hole, you know that the maximum stress concentration, the maximum stress point is the point that is 90 degree to the applied load. So we have applied the load in this direction, 0 degree, and the maximum stress occurs at 90 degree to this applied loading direction, that is this point and this point. So here we have maximum stress comes at these points, and the maximum stress value comes to be 293, and we know that the stress concentration factor, the maximum stress concentration factor in a plate with the hole is 3 times the applied load. So we have applied 100 MPa, and we are getting almost near to 300 MPa. So we can also look at the displacements here. So now you can see that the plate is displaced in this fashion. So we can see all these results, and we can change the axis and see, observe this. So you can see that the plate has not moved in the Z direction, it has moved only in the X and Y. So you can change the axis and you can check. So now you can see the plate hasn't deformed in the with respect to Z. Similarly, you can see the other results as well. You can look at the displacement magnitudes and any other components of displacement, X displacements you can see. And in the stress tensor, you can look at the X component of the stress, and similarly you can look at the Y component of the stress. And basically you will not have any Z component, but well, you can still look at it. And we have many other stress components that you can see. So if you want to see only the deformation, then you can just reset the graphics and click on only the deformation. You can click apply, and you can see that you can see the deformed and undeformed as well. And here it shows the maximum displacement 1.63 into 10 power minus 1, and that's what you see here. So basically this is it. So